Hello, this is Ashlee and Danielle. We chose to do our extra credit on the biomechanics of the hip joint in healthy individuals. As we learned in class, the hip joint is an integral joint in the human body that helps support a person's upper body as well as move their lower body. We conducted some research on this topic and found a very interesting and basic article that talks about the hip joint from an anatomical perspective and then looks into its role as a joint and how when it's replaced, forces can vary. In the article, titled Anatomy and Biomechanics of the Hip by Byrne et al., they say it best in their introductory paragraph. The hip is a true ball and socket joint surrounded by powerful and well-balanced muscles, enabling a wide range of motion in several physical planes while also exhibiting remarkable stability. As a structural link between the lower extremities and the axial skeleton, the hips not only transmit forces from the ground up, but also carry forces from the trunk, head, and neck, and upper extremities. Consequently, this joint is crucial to athletic activities in which it is often exposed to many greater than normal axial and torsional forces. This paragraph we've just read from, taken from Byrne et al., touches on a lot of the concepts that we've spent this past semester learning about. It talks about the different planes of the body that we learned about that are the transverse, sagittal, and axial planes. As we learned, since the hip is a ball and socket joint, it has motions in all three planes. This is part of what makes it such a powerful and crucial joint. Their paragraph then goes on to mention how it transmits forces from the ground, but the ground and body itself also exert forces on it. We spent a lot of time on free body diagrams in class, and we have chosen to include a free body diagram in this video about a normal hip in stance phase before running. Lastly, in this paragraph, they mention axial and torsional forces, which we also learned about in class, which are defined as a force that is applied to the center line of a shaft and then the twisting of an object or bone because of an applied torque, respectively. We have also chosen to include a net muscle over time graph that looks at muscle forces in not only the hip joint, but also the knee and ankle joints. Ashlee will now explain both of these images.
So we drew some very basic free body diagrams of the hip in the beginning stance phase. So here we have like the muscle force from the hip flexors, the force of the weight, and then the vertical and horizontal ground reaction forces. And then we also drew a kinetic diagram showing the way the acceleration is the way in which the acceleration is going. And then we drew a mechanical running model for power of the joint. We did it both for the ankle, knee, and the hip. And as you can see, like in the stance phase here, the ankle exerts the most power, the knee second, and then the hip exerts the least amount of power. But however, in the swing phase, it's very variable between the three of them.
Alright, that's it. Thanks for watching.